So in 3.2, we are going to discuss about the periodicity, which is the trends in element properties. Okay, the first properties we are going to have a look at is the atomic size. So across a period in the periodic table, okay, across a period from left to right, for example, in period 3, we have sodium, magnesium, aluminium until group 18 of argon. So as we can see, from sodium to argon, the proton number increases, right? So the proton number increases. So the proton number of sodium is 11, magnesium 12, aluminium 13, okay, and until argon we have 18 proton number. So the proton number is increases. So when the proton number increases, the effective nuclear charge also increases. So what is the effective nuclear charge? For example, if you have sodium, okay, that is equals to 11, okay. To find the effective nuclear charge, okay, we label it as ZEF here, okay, is equals to the number of electron of sodium, which is 11, okay, minus with the inner electron. So how to find the inner electron? Okay, so we have the electronic configuration for sodium 1s2, 2s2, 2p6 and 3s1. So the 3s1, okay, the 3s1 here, we call it as the outermost shell. Okay, the outermost shell. So the electron in this 3s orbital of sodium is the outer electron. Okay, so this is the outer electron, and all of this electron in this in this one s2, 2s2 and 2p6 orbital, this one we call it as inner electron. Okay, so the inner electron of sodium is 2 plus 2 plus 6. Okay, so we got 10 electron. Okay, so the effective nuclear charge of sodium is 11 minus 10 equals to positive 1. So you can do the same for magnesium, aluminium, silicon until argon. So you can see that the effective nuclear charge from sodium to argon is increases. Okay, so sodium positive 1, magnesium positive 2, aluminium positive 3 and so on. Alright, so when the effective nuclear charge increases, the positive charge felt by the outer electrons also increases. So if we draw it like this, okay, sodium, the effective nuclear charge is positive 1, okay. So this is sodium, all right. The first shell, okay, the first shell, n is equals to 1, we got 2 electron, okay, we got 2 electron in the first shell. The second shell, okay, the second shell, n is equals to 2, we got 8 electron, 2 plus 6 is equal to 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then for the last shell, n is equals to 3. Okay, we got 1 electron. So when the when the effective nuclear charge increases, okay, the positive charge felt by this outer electron, okay, electron is in negative charge, okay, so the positive charge felt by the outer electron also increases, okay. So when it's happened, okay, the nucleus and the outer electrons attraction are become stronger, okay. If the positive charge felt by the outer electron increases, the attraction between the nucleus and also the outer electron, okay, become stronger, okay. Thus, okay, the atomic size decreases, okay. So we can see from sodium to argon, the atomic size is decreases. How about the trend in atomic size down a group? So for example, if we take group 1 element, we take from hydrogen, lithium, sodium, potassium, and so on down the group, okay, we can see that the number of shell increases. So what is the number of shell? So let's take lithium and sodium as example. So lithium, okay, proton number is equals to 3. So the electronic configuration for lithium is 1s2, 2s1. Okay, so since the principal quantum number in lithium only n is equals to 1 and n is equals to 2, so lithium got 2 shell. Where plus here the effective nuclear charge for lithium, okay, effective nuclear charge for lithium, so it got 3 electrons minus with 2 inner electrons, okay, equals to positive 1. Okay, so for the first shell, it got 2 electron, 1, 2. And then for the second shell, it got only 1 electron. So lithium got 2 shell, okay. And for sodium, okay, sodium, Z is equals to 11. So we have 1s2, 2s2, 2p6, and 3s1. Okay, so we already calculate the effective nuclear charge for sodium, and also we already draw this one, okay, just now. So here we can see that sodium got 3 shell, n is equals to 1, n is equals to 2, and n is equals to 3. So as the number of shell increases from up to down, okay, down the group, all right, so the shielding effect also increases. So the shielding effect is the effect that is felt by the outer electrons, okay, the effect that is felt by the outer electron, where the inner shell of that elements, okay, inner shell is shield the outer electron from the attraction of the nucleus. Okay, so kita ada inner shell, okay, inner shell ni dia akan shield the outer electron daripada tarikan positive charge of the nucleus. Okay, that is the shielding effect. So maksudnya makin banyak inner shell, okay, makin banyak inner shell, makin terhindarlah the outer electron ni daripada tarikan nucleus. So that also will make the distance between nucleus and the outer electron farther. Okay, dia akan membuatkan distance, jarak antara the nucleus and also the outer electron semakin bertambah. Okay, jarak dia semakin bertambah. Kalau tengok dekat lithium ni, lebih dekat jaraknya dengan nucleus, the outer electron lagi dekat dengan nucleus, tetapi sodium lagi jauh sebab ada pertambahan shell. We got the inner shell lagi banyak berbanding dengan lithium. Okay, and then that makes the attraction of the nucleus and the outer electron weaker. Okay, so makin banyak shell, makin banyaklah shielding effect, makin jauhlah jarak antara nucleus dan the outer electron, and it will make the attraction weaker. Thus, the atomic size increases. Okay, so down the group, our atomic size semakin besar. And the last thing in atomic size trend is we are going to look at the first row of the transition element, which is from scandium, titanium, vanadium until zinc. Okay, so for this transition element, we can see that at first the atomic size decreases, but after that it remains fairly constant. Okay, why does this happen? This is due to the d electrons fill the inner orbitals and shield the outer electrons from increasing the nuclear charge much more effectively. So this make the outer 4s electrons are not pulled closer to the nucleus, okay, and also the atomic size remain constant.